everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about metal alloys, and this is for GCSE chemistry. I hope you guys do find this video helpful. If you do, feel free to let me know by giving the video a thumbs up. You can also share this with someone to help them with their revision as well. And if you'd like more revision and helpful tips, feel free to subscribe. Join this amazing community. It's absolutely free. And thank you so much for your support and subscribing to this channel. Let's get started. Let's talk about alloys. So we've probably actually seen alloys more than we realize. They are pretty much everywhere. Metal alloys specifically, if we look at any buildings, a lot of the metals that are used are alloys. The cars, perhaps even like Formula One cars, for example, super high-tech vehicles, those have alloys, but even just, everyday transportation like trams, bikes, cars, buses, all of that will have some alloy components as well. Even items like our jewelry or the cutlery that we use on a daily basis for consuming food, even to the different aerospace technology that we have with exploring the universe. There are loads and loads of different examples of alloys. And in fact, the first alloy was actually bronze, and this was made around 6,000 years ago. So we have had this technology for a really long time, and it's just a reminder really that science is absolutely everywhere, and we should always question what is going on around us and the world around us. So let's look at what an alloy actually is. So, an alloy is essentially a mixture of two or more elements where at least one of those elements is a metal. So, we often call them metal alloys because of that metal component. And the reason we make metal alloys is because many pure metals are actually incredibly soft. If you've ever done the Group 1 metal practical where your teacher maybe takes a teeny tiny bit of metal, throws it into some water carefully, the metal will actually combust. It will actually make a very, nice flame, that kind of thing. Can fizz on the surface because it's very reactive, specifically Group 1 metals in that case, as you go down the group. But that being said, those metals like sodium, for example, or lithium are incredibly soft. You can actually cut them with a scalpel. So although that's great for that practical, in everyday use, we see metals as very hard wearing, durable substances. But the reason that happen is because often those metals are mixed with something else to give them that specific quality. So for example, pure iron is actually incredibly soft. So we have to mix it with a few other things to make it the way it is. So for example, we can add things like tungsten to iron, and that can make steel, which is much harder and much more hard wearing. And there's other alloys as well that we can see. So for example, bronze, I know I mentioned a moment ago, that's a mixture of copper and tin. Brass is an example where copper and zinc is used. White gold in a lot of jewelry. This is a mixture of gold and silver. And there's so many different examples. And we're going to explore this in more detail. But we need to also think about, okay, so why are metals soft in the first place? Let's actually explore that now. So if we actually look at the molecular structure of metals, we can actually see they have a giant metallic structure, often in layers, and those uniform layers are able to slide over one another. And amongst the atoms of those metals, especially in pure metals, you can see we've got a really nice uniform structure. Those layers, like I said, can slide over one another. There's also a sea of delocalized electrons, which are electrons that are free to move. So that means that essentially electricity can be conducted, that movement of charge. That's why metals like copper are such great conductors of electricity. But at the same time, because those metal structures, the molecular structure of it is in those nice uniform layers, those layers are really easily moved with very little force. And of course, we're talking molecularly here. So if we were to apply a small amount of force, like cutting a very small piece of sodium, it's very easily done. However, with an alloy, because we've now got a mixture of atoms that are, of course, different sizes, this actually distorts those uniform layers slightly. And this means that more force is required to make those layers move across one another, which therefore gives it strength. So essentially, the more distortion there is, that actually means the more force that's required. And that's why those alloys can be used to strengthen metals. And that's why they're therefore used as opposed to just pure metal itself. So it's pretty cool to see it on a molecular scale like this. So, some key examples that they really want you to know is the steel example. So, I know I've mentioned steel before as an alloy, but there's actually a few different types of steel. So, we have mild steel, for example, which is made of carbon and iron. Now, remember, an alloy doesn't have to just be metals, a mixture of metals. It can be a metal and a non-metal as well. In this case, remember, carbon is a non-metal. It's on the other side of the periodic table, on the right-hand side. But mild steel, because of this carbon, is very ductile, it's very bendable, so it can be used in things like wires and gates and things like that. We've also got stainless steel, a really good example of some of the items you may have in your home. So things like the kitchen items like forks, spoons, knives, frying pans, tins for baking, that kind of thing. These are all examples of stainless steel. They are made of something called chromium and iron, and they're very hard wearing, as we know. They're rust resistant as well, so really useful when obviously you're having to wash these items a lot. Rust is obviously avoided because it's rust resistant, and rust is when there is water and oxygen essentially reacting with that iron. So that's the iron oxide, is the rust that's forming there. So this is rust resistant, which is great because of that chromium element as well. And then we also have tool steel, and tool steel is made of tungsten and iron, like I mentioned earlier. Like I say, it's very hard wearing because it's often used in industrial machinery, so it has to be able to withstand very high pressures, temperatures, and be very, very hard wearing in itself. So these are some key examples that you should know. Remember, steel, the key components of all of these is iron. Remember, steel is this ferrous metal. It has iron to it. It's also, because it does contain iron, it's also magnetic as well. So that's just something else to be aware of. And if you'd like to learn more about magnetism, I have done a video on that too. Thank you so much for your time today. I have been the GCSE science teacher and you have been curious. If you did enjoy this video or would like to make a video request, feel free to do so in the comment section. And I hope you guys have a great day. If you, like I say, want more revision from me, I will link some for you either here on the side, and you can also check out my Instagram and TikTok at the GCSE science teacher if you want more bite-sized revision. In the meantime, like I say, have a fantastic day and I'll catch you in the next one. Take care.